What's going on, everyone? Welcome back. Patrick here, and moving on to the next concept in this video, I want to talk about the difference between the inverse of a function and an inverse function. So notice so far in the last few videos, I've always been saying inverse of a function. But sometimes you may see your prof, or you may see textbooks, even whole chapters, referred to as inverse functions. So what's the difference between these two? Well, it's pretty simple. I'll show it to you visually. So let's say that we have a function, f of x. Now, we can find the inverse of this function, and there's going to be two possibilities. Either the inverse, which is denoted as that, either the inverse is not a function, or the inverse is a function. So either the inverse is going to fail the vertical line test, or the inverse is going to pass the vertical line test, which means it's then a function. And this is basically what an inverse function is. Right? So an inverse function is when the inverse of a function is a function. Okay, hopefully that made sense there. So it's basically when the inverse is a function. So for example, let's say that we have the function x squared plus 3. Okay, so if we graph that, that's just x squared shifted up by 3 units. So it's up here. So the vertex is at 0 and 3. So that means the inverse, we know the inverse of a parabola is always going to be a sideways parabola. And the vertex of the function, this is f of x, is 0 and 3. So the inverse is going to have a vertex at 3 and 0. And it's going to be facing this way. Because the range of the function is greater than or equal to 3, the y value of the vertex, so the domain of the inverse is going to be greater than or equal to 3. So this is the inverse here. So notice that this inverse is not a function because it's failing that vertical line test. But let's take another function. Let's take x cubed, for example. Now, x cubed, if you were to make a table of values for it, it would look like this. So that would be x cubed. Now, if you were to take that table of values for x cubed, so let's say you went from like negative, the x values would be from, you know what, let me just draw it out actually. So we got x cubed, we got -2, -1, 0, 1, 2. So we'd have -8, -1, 0, 1, and 8. If you were to take these points and then interchange them, right, so all the y values became x, all the x values became y, and then plotted that, the way that would look, you'd get something like this. This keeps going down forever, this keeps going up forever. So that's how the inverse of x cubed looks like. And notice in this case, the inverse is a function because it's passing that vertical line test. So an example of where an inverse is not a function, and here where it is a function. And so this here is an inverse function, right? Because the inverse is a function. Okay, hopefully you're not getting too confused about the wording there. Now, here's why this is important, is because in order for the inverse to be a function, the original function f of x has to be 1-to-1. And that's where that 1-to-1 concept comes in now. So if a function, the original function, if it's 1-to-1, that means that its inverse is going to be a function. Okay, and we can see that with both of these. So notice that this parabola x squared plus 3, notice that it fails the horizontal line test. Remember, to test for a one-to-one function, it's not a vertical line test, it's a horizontal line test. And notice that f of x here, it fails that horizontal line test, meaning that there are multiple x values for a single y value. And so because f of x is not a one-to-one function, notice that the inverse is not a function. Remember, for the inverse to be a function, the original function has to be one-to-one. But notice x cubed, it is a one-to-one function because it passes that horizontal line test, which means that the inverse is a function. It passes the vertical line test, right? And so that's how that one-to-one and the inverse relate. And yeah, that's pretty much it. So when they're talking about inverse functions, just remember that they're talking about the inverse being a function. There are two possibilities here. Either the inverse is not a function or it is a function. And if it is a function, you could call it an inverse function. And one more thing I actually want to mention is, if you remember, we were able to restrict the domain for f of x sometimes in order for the inverse to be a function. We did a couple of videos on that. So let's say we restrict this domain here. So let's say that instead of XER, all the x values have to be greater than or equal to 0 for this function, which means all the y values for the inverse have to be greater than or equal to 0, which means we would get rid of this leg over here. Well, notice now that the inverse is a function. It passes that vertical line test, and notice at the same time that the function now is one-to-one because it passes that horizontal line test when we restrict its domain. There's not multiple x values for a single y value anymore in the original function, right? So thought I would make a note of that, because we're going to be working with a lot of functions where we have to restrict their domains in order to have an inverse function, right? In order for that inverse to be a function. And so sometimes restricting that domain in the function makes it one-to-one, which allows that to happen.